Hey everybody, hopefully you're here because you want some help or guidance on the study guide and review. I'm only going to be doing the ones that we did not go over together in class. So if we don't go over one of the ones you want today, go back and go to the class recordings from the class that we reviewed, and then you can look for those solutions there as well. Hopefully you were just, going along with me. But the one that we didn't go over today in class was number 8. Where we're looking for inverse variation, where we relate x equals 5 over 2 when y equals 18, and then they want us to find y when x equals negative 3. So remember, inverse variation, the formula is y equals a over x, okay? So knowing that, first step, we're going to find the equation, which means I'm going to use this and plug it into here and here to find that value of a. So we get y, which is 18, equals a over x, which is 5 over 2. Now to get a by itself, I'm going to multiply both sides by 5 over 2. Because it's being divided by 5 over 2, I can multiply it by 5 over 2 and they cancel. We get a equals 5 over 2 times 18. I know I can cross cancel the 18 and 2, which becomes a 9 and a 1. That becomes 9 times 5 is 45 equals a. So my equation is y equals 45 over x. So that's my equation. And now I'm going to use that equation to find y when x is negative 3. So we say y equals 45 over x, which is negative 3. So that's how we get y equals negative 15. Okay, let's skip on to the next one that we did not go over in class, which is number 15, which is graphing. So we're going to graph h of x equals 6x squared all over x minus 2. So first things we're going to do is we're going to do our 3 steps. Remember, so step 1, we're going to find the zeros. And then second step, we're going to find the vertical asymptotes. And then the third step, we're going to find the horizontal asymptotes. So remember, 0, we take the numerator and set it equal to 0. So we say 6x squared equals to 0. We're going to solve for x, divide by 6. We get x squared equals 0. Take the square root of both sides, we get x equals 0. So as I'm graphing that, we're going to put that here. Sorry, it's not making a straight line for me like it normally does. And then we know x is 0 is going to be on the x-axis right at 0. So that is remember the 0 is another word for x-intercept, which is just a point. Okay, so now we're looking for where does the vertical asymptotes. Okay, remember we take the vertical asymptote by taking the denominator and setting it equal to 0. Solve for x. We got x equals 2. So when x equals 2, we have that vertical asymptote there. And then lastly, we've got our horizontal asymptote, but remember we're going to compare the degrees. So you want to make sure that you have your horizontal asymptote chart to tell us what goes where. So I know I'm going to look at the degree on the top, which is a 2, and the degree on the bottom, which is a 1. And in this case, the degree on top, which is the numerator degree, is greater than the one on the bottom. Since this is the case, the numerator on top, the degree is bigger than the one on the bottom, then there's no horizontal asymptotes. All right, so those are our first 3 steps. And then our next step is we're going to make our t-chart. Remember, we're going to pick 2 values to the left of the vertical asymptote. So I'm going to pick x equals 1 and like negative 1 because we already picked 0. So let's pick 1 and negative 1. And then we'll pick 3 and 4. And I'll use a different color because that lime green is really hard. And then we're going to plug it into whatever the y equals, which was right here, 6x squared divided by x minus 2. So we're going to go 6 times 1 squared divided by 1 minus 2, which is 6 over negative 1, which is negative 6. So the point that we're going to plot here is 1 comma negative 6. 6 times negative 1 squared all over negative 1 minus 2 is negative 3 on the bottom, and this is a positive 6 on top, which becomes negative 2. So the point here is negative 1 comma negative 2. And then 6 times 3 squared all over 3 minus 2. We put 1 on the bottom. 3 squared is 9 times 6 is 18. And then we go 6 times 4 squared all over 4 minus 2, which is 4 squared is 16 times 6. I think that's 96 divided by 2 is a really big number, which is 48. That's giant. Okay, so we're going to plot these points now, or at least something that represents those points. The 48 is going to be really tall. So I'm going to go back over here. Now remember, the points don't have to be exact. We're just kind of looking for the overall shape of what the graph is going to look like. So that point negative 1, comma negative 2. So here's negative 1, negative 2. That's this point right here. That was this point. 1 comma negative 6. So we go over 1, negative 1, 2, 3, 4, 5, 6. So here's negative 6. That's this point. So I know that we're going to be able to graph these points like this. Okay. And then 3 comma 18 is way over here at the top. And 4 comma 48 is even farther at the top. So the way that we're going to graph this one, it actually, remember, here's the rest of my vertical asymptote. It's going to look something like this. It's going to kind of look like a boomerang. But basically what I'm looking for when you graph it is that you're not crossing over the asymptote, that you've got your 0, you've got your vertical asymptote there, and you've got your couple of points, and you're showing me that it does not cross the asymptote. All right, there's number 15. Let's go ahead and do number 17, where we're going to graph y equals x squared plus 6 all over x squared minus 3x minus 40. And you might think, oh, Mrs. Salz, this sounds really crazy. It's not. So remember, we do our 4 steps, which are zeros, the vertical asymptotes, the horizontal asymptotes, and then you're going to find your XY chart. So remember, zeros, we always take the numerator and set it equal to 0. So x squared plus 6, set it equal to 0. And solve. In this case, we end up with x squared equals negative 6. Well, when I take the root of that, can I take the root of a negative? No, we can't. So there's none on this one. For the vertical asymptotes, we're going to take the denominator and set it equal to 0. So we end up with x squared minus 3x minus 40 equals to 0. Now, in order to solve this, I'm going to factor. So I'm going to factor this down. I know there's 3 terms. What multiplies to 40 and adds to negative 3? Well, I know, let's see. How about 8 and 5? Where the 8 has to be negative. The 5 is going to be positive. So we get x minus 8 and x plus 5 equals 0. Now, I know something times, so when this quantity times this quantity equals 0, each of those have to be 0. So then we can say x minus 8 equals 0 and x plus 5 can equal 0. So we get x equals 8 and x equals negative 5. Okay. So those are my vertical asymptotes. So when I graph that on my graph over here, oh, come on, I need a straight line. There we go. And we've got to got 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis and negative 5, 1, 2, 3, 4, negative 5 right here. Our vertical asymptotes are negative 5 and 8. So they look like this. So there's our vertical asymptote. And here's our vertical asymptote. So we have really 3 regions now that my graph can exist. And then for our next step, we're going to be looking for the horizontal asymptotes. Remember, we're going to look at both of the degrees. So I see here the degree on the top is 2 and the degree on the bottom is 2, which means now they're the same. So that means we're going to go in front and look at the coefficients. So the 1 is in front here and 1 is in front here. So those 1s tell me what the horizontal asymptote is. So since the degrees are the same, then we look at y equals a over b, which is 1 over 1. 1 over 1 is just 1. So our horizontal asymptote is when y equals 1. That looks like this. Okay, so we've got my zeros. We didn't have any. Vertical asymptotes, we had 2, and horizontal asymptotes, we have 1. So now we're going to pick two points to the left and the right of each vertical asymptote to know where we're going to graph these. So here we go. If this is my vertical asymptote here, 2 points to the left are going to be -6 and -7. And then any 2 to the right, it doesn't really matter. I'm going to pick 0 because it's easy, and 1, okay? 0 and 1 are also to the left of 8, so that works for that. Okay, so there's my left-hand side of the left vertical asymptote. Here's the right-hand side of the vertical asymptote, or the middle section. And then I'm going to find 2 to the right of the vertical asymptote, which of 8, which is 9 and 10. So I'm going to take those points. Now, could you have chosen a bunch of different points? Absolutely, but I'm trying to pick the least amount as possible. So here we go. We're going to plug these back in to our original equation, which was x squared plus 6 all over x squared minus 3x minus 40. So here we go. We're going to plug -6 in, so we go -6 squared plus 6 all over. And again, you can totally plug this into your calculator. I suggest it when you plug this in. So I'm plugging it in my calculator right now. And we get 3. If I plug in -7, I'm going to just do all that work, right? -7 squared plus 6 all over -7 squared minus 3 times -7 minus 40. We end up with 1.8 approximately if I round it. And then here I've got 0 squared plus 6 all over 0 squared minus 3 times 0 minus 40. And we get -0.15. And if I get 1 squared plus 6 all over 1 squared minus 3 times 1 minus 40, we get -0.17 if I round. And if I got 9 squared plus 6 all over 9 squared minus 3 times 9 minus 40, we end up with -0.375. And then if I plug in 10, we get 10 squared plus 6 all over 10 squared minus 3 times 10 minus 40. We get about 3.5. Okay, so we're going to list all those points. So this is -6, comma 3, -7, comma 1.8, 0, comma negative, I'm going to round this to 0.2, 1, comma -0.2 if I round it. Actually, I don't want to do that because it's going to be too far off. So we'll do 1.5 and 1.7. That just shows you which one's above and which one's below. This will be 9, comma -0.4, and this will be 10, comma 3.5. So we're going to plot those, plot those points here. So -6 is right here, okay? And then we're going to go up to 3. So here's 1, 2, 3. So that's this point right here. -7, comma positive 1.8 is about right here. And we can see how that's going to follow right there. Okay, so there's that. And then at 0, we're at -1.5, so it's just below the line here. And at 1, we're at -0.17, so we see it's going to go down. So we see this looks like it's going to go like this. And then at 9, it's at negative 0.4. So again, like this. And at 10, it's at that can't be right. That can't be negative. It's got to be positive. Let me go back. Oh, yeah. When I plugged this one in, sorry, I'm going to go back and change it. I wrote the wrong thing down. Should have been 6.2. I was like, that can't be right. It can't be negative. So at 9, it's at 6.2, which is up here. And at 10, it's at 3.5, which is about right here. So it's going to look like this. All right, and that's our graph for number 17. All right, let's do our next one that we didn't go over in class list 21. We've got 16x squared minus 8x plus 1 all over x cubed minus 7x squared plus 12x. Where we're gonna, oh, I'm not done writing it down. Divided by 20x squared minus 5x all over 15x cubed. So keep in mind, when we divide fractions, we're really multiplying by the reciprocal. So I'm going to change this to multiplication, and I'm going to flip the second one by the reciprocal. So I'm multiplying by 15x cubed all over 20x squared minus 5x. And then the first one stays the same. Okay, so now that we know we're dealing with multiplication, we're going to factor everything so that we can cancel on the top and the bottom. So now we're going to factor everything on the top and the bottom. So again, let's look at this first. So I see there's no GCF. There's a 16 in the front and a 1 here. So then since there's 3 terms, I'm going to X factor. I get 16 times 1 is 16. And negative 8. What multiplies to 16 and adds to 8? How about negative 4 and negative 4? If I pull this out, I get 16x squared minus 8x plus 1. I'm going to split that negative 8x into the negative 4x and negative 4x. Bring down the plus 1 here. Bring down the 16x squared. Now that there's 4 terms, I know I'm going to do grouping, because when we saw that 3 terms with the 16 on the A value, we know we had to use X grouping. So now I'm going to pull out a GCF here, which we get a 4X, and we're left with 4X minus 1. And I'm going to pull out here a negative 1, and we're left with 4X minus 1. Ooh, it's so cute. And it's cute because we have twins. So this is now the GCF of both sides, which is 4X minus 1. And we're left with 4x minus 1 again. So this one on top became 4x minus 1 times 4x minus 1, and this is now gone. Okay? So let's factor this one on the bottom now. So I see 1, 2, 3 terms. And there's an x here. I forgot to write it down. And we can actually pull out a GCF of an x. So we get x squared minus 7x plus 12. What's left is 3 terms. And we know we can factor those 2 down. What multiplies to 12 and adds to negative 7? Well, I know 3 and 4, if they're both negative, can work. So we get x minus 3 and x minus 4. Don't forget this x in front. So we just factored all that down. This replaces it. And then the last one we have to factor is this one right here. I'm going to pull out a GCF of 5x, and we end up with 4x minus 1. Okay, so now we're ready to cancel as much as we can, okay? So I'm looking here, and I see on the top and the bottom, I see a 4x minus 1 and a 4x minus 1. So I'm going to cancel those. Or else do I see something alike? I see here that there's an x, and there's 3 x's here, so I'm going to take one of them out. That leaves me x squared on top, and this one's gone. Other than that, I don't see, oh, I do see one more thing. I see a 15 and a 5 that can reduce to a 3 over 1. So here's what I'm left with. I'm going to go ahead and highlight it in yellow. I've got 4x squared on the top, a 3, and an x squared. So we've got that 4x minus 1 on the top and a 3x squared. We're left with x minus 3 on the bottom, x minus 4 on the bottom, and that's it. So this is our simplified answer. Okay, so that was 21. We're going to go ahead and do 23. We also didn't get to in class. So we've got 5 over 6 times x plus 3 plus x plus 4 over 2x. So we need to add these, but remember, in order when we add or subtract, we have to have a common denominator. We don't have a common denominator here and here, so we need to find a common denominator. So let's find our common factors first. So 6 and 2 could both have a 2 in there. But x plus 3 is a different factor than x. So now we're going to take what's not common, which in the 6 we had a 2 and a 3. The 2 was common, but the 3 is not. So I'm going to multiply it by the 3. I'm going to multiply it by the x plus 3. And I'm going to multiply it by this x. So I'm left with 6x times x plus 3 is my common denominator. Now, okay, so I've got 6 times x plus 3. I need another x. So I'm going to multiply the bottom by x and the top by x. On the right side, I've got 2x. I need it to be 6x times x plus 3. So I need another 3 and an x plus 3 on the top and the bottom. So now I've got the same denominator. So I've got 6x times x plus 3. Beautiful. So this becomes 5x. And then this is going to take a little bit more work. So here's what I'm going to do. I'm going to write this in parentheses first, and then I'm going to distribute. Okay, so this 3x times 3, this becomes a 3x plus 9. I'm going to take a minute and redistribute just this part. I'm going to FOIL this first, which is 3x squared. Outer is 9x. Inner is 12x. And last is 36. Okay. And the rest I'm going to bring down. And don't worry about the denominator quite yet. Now I'm going to simplify the top by combining like terms. I know like terms, okay, I've got 3x squared. That's the only one of its kind. Let's talk about the x's now. So we've got 9x, 12x, and 5x. So that becomes a total of, let's see, 26x. And then we know 36 doesn't have anything it can combine with, so it's just by itself. And then we're all over 6x times x plus 3, which there's nothing else we can factor out, nothing else we can cancel. So this is our final answer. Okay, let's do 25. We've got x plus 2 all over x squared plus 4x minus 3 minus 5x all over x squared minus 9. Okay, so again, we have to have a common denominator because we're subtracting. Right now, we definitely don't. So we need to factor both of these first before we can find a common denominator. So I know this one here is 2 terms, no GCF. If there's a minus in the middle and perfect squares, this becomes a difference of 2 squares, x minus 3 and x plus 3. Here, I know there's 3 terms, no GCF. So what multiplies to negative 3 that adds to 4? And I think we would get what? Oh, sorry, this is supposed to be a plus, excuse me. I wrote it down wrong. We'd get 3 and 1. So we get x plus 3 and x plus 1. So now this is gone and this is gone. So what do these both have in common? Well, I see that they both have an x plus 3 in common. So the common denominator is definitely going to have the x plus 3, but now we multiply in the non-common factors. So x plus 1 is one of them, and x minus 3 is the other. So this is going to be our common denominator. So now that we've got that, I need to figure out, okay, what needs to be multiplied to the denominators so that I can get this common denominator? Well, this left side, I've got x plus 3 x plus 1, and I'm missing the x minus 3. So I'm going to multiply that on the top and the bottom. And then this one has x minus 3, x plus 3, and I'm missing the x plus 1. So now that these are all the same denominator, I'm going to write it all down. And then the numerator is what I'm going to do here. So I'm going to FOIL first, outer, inner, last. I get x squared minus 3x plus 2x minus 6 minus 5x times x is 5x squared. And then don't forget this minus also goes to both parts. So 5x times 1 is 5x. I'm going to simplify and distribute that negative to both of these parts. So we end up with x squared minus 3x plus 2x minus 6 minus 5x squared minus 5x. Leave the denominator factored just the way that it is. And now we're just going to kind of clean this up. I've got a negative 3x squared, a 2x, and a 5x. And then I also have a 5x squared and an x squared here. So we can combine those terms. So we get negative 4x squared. Negative 3 plus 2 is negative 1x minus 5 is a negative 6x. And then this negative 6 is left behind. So we just write that. And there's nothing here that can be factored again and simplified. So this is our answer. Okay, last one, or last two. We're going to simplify this one by multiplying. 5 over x equals 7 over x plus 2. We're going to cross multiply. So we get 7 times x equals 5 times x plus 2. Remember, we can only cross multiply when we see an equal sign and two parentheses, or two fractions. We're going to distribute. And we get 5x plus 10. Solve for x. Whoops, I crossed out the wrong one. This is the one we crossed out. And we get 10 equals 2x. Divide both sides by 2. X equals 5. Okay, so that was 26 and 27. So remember, again, it's a lot easier when you don't have to add or subtract with common denominators. It's a lot easier to solve and simplify. And then 27 is x plus 12 over 3 equals 2x plus 3 all over x plus 2. Okay, so again, we're going to cross multiply because we've got two fractions and an equal sign. So we're going to multiply x plus 2 times x plus 12 equals 3 times 2x plus 3. And now we're just going to simplify that. So we're going to go FOIL, first, outer, inner, last. So x times x is x squared. X times 12 is 12x. 2 times x is 2x. And 12 times 2 is 24. And we're going to distribute the 3 here. And now let's get everything to the same side because we've got an x squared with a bunch of x terms. So we don't want to have, we can't solve directly for x. So we're going to just move everything over to one side. And we get x equals 0 on, or 0 on the right side. X squared, we get 12x, and 2x is 14x minus 6x is positive 8x, and 24 minus 9 is positive 15. So to solve this, I've got 3 terms. There's no GCF, so I'm going to have to factor this. What's going to multiply to 15 and add to 8? I know 5 and 3 can work. And then in order to solve this, remember something times something equals 0 means that each of those things has to equal 0. So we get x equals negative 5 and x equals negative 3. And those are my answers for that one. Okay, that's it for now. Let me know if you have any questions. Come see me during tutoring after school. Bye.